Welcome to Lesson 3B, Greenhouse Gases. Let's talk about greenhouse gases, climate change, and global warming as those abbreviations. Some examples of greenhouse gases. H2O is the primary one, water vapor. It contributes most to this greenhouse effect than any other gas. CO2 is the one that's always in the news, and we're going to be talking about that one mostly. And then methane is also a greenhouse gas, much more powerful than CO2, but there's very little of it in the atmosphere, so it doesn't have as big of an impact. And then there are others like N2O, nitrous oxide, that have a more minor effect. So here's the definition of a greenhouse gas. It's a gas that absorbs radiation from the sun and then traps it into the atmosphere. Here's the sun, here's the earth, here's the atmosphere. What happens to the radiation that comes from the sun? Some of it hits the ground and gets absorbed, so it warms up the ground, warms up your skin when you're outside, you can feel it. Some of it reflects. And then there's lots of molecules, gas molecules, and even some particles in the air that can reflect some of that radiation. And because of the greenhouse gases, the atmosphere is like a glass on top of a greenhouse, and it traps some of that heat inside. Of course, some of it escapes. So this reflected and trapped radiation is what leads to global warming, or now more common term is climate change, and so it heats up the earth. So let's talk about CO2, since that's the one that's always in the news. Is CO2 a cap? Well, you should remember your CAPS criteria, air pollutants. It is not. CO is one, but CO2 is not. It's not an air pollutant in the sense of a cap. Is it a HAP, a hazardous air pollution? No, it's not on the list. So can we call CO2 an air pollutant? Well, certainly it's not a typical air pollutant because it's not toxic. The only way it's harmful is if you have very high concentrations so that it replaces some of the oxygen that's in the air, and then you could have some problems, namely a lack of oxygen. But it's not an air pollutant in the traditional sense, but it is a global warming gas or a greenhouse gas. So it does contribute to some of the warming on the earth by its interaction with radiation from the sun and the atmosphere. Here's a scale or a spectrum from what I'm calling the far left all the way to the far right, and then I'll talk about some various topics within that. First, some nicknames or kind of derogatory terms. People on the far left would be called climate change alarmists or doomsdayers. People on the far right would be called climate change deniers or science skeptics, and we can do some other topics here. For example, let's look at some of the claims. On the left, global warming is a crisis. It's the most important issue. It's an emergency. On the far right, it's a hoax. Global warming policies are going to destroy the economy. Global warming has nothing to do with human beings. It's all natural. Whatever's going on is natural. In terms of politics, typically the liberal Democrats are on the far left and the very conservative Republicans are on the far right. So just like it is in politics, which is why I drew this scale, it kind of goes along right with that. Emotionally, well, you can see by the faces I drew, both sides get angry about this stuff. And finally, religious on the left are typically atheists or liberals, on the right are typically conservatives. So the question we need to ask here is, where is the truth in this scale? And I would answer that it's somewhere in the middle. I don't know where in here, but we're not on the far left or not on the far right. Probably somewhere in the middle is where the truth lies. So what I'm going to do today is just look at various evidences, as much as I could gather from the internet mostly, and try to stay neutral on all this, as much as possible to stay neutral, and just look at the facts and give you kind of both sides of the argument here. So I'm going to look at some plots to see if global warming is true, and if so, are the CO2 emissions causing global warming? So I'm going to look at temperature plots first. It depends on where you get your plots from, and there's a lot of bias, and I want to keep emphasizing that there's bias in the media and bias in pretty much any articles you look at. So here's global average temperature, but they don't tell you in this article how or where temperature was measured, and you can see that temperature was pretty much flat for a long time, and then about 1970 or so, it starts increasing here. So the temperature is up since 1970, according to this plot. Here's some data from meteorological stations. So these are direct measurements of global temperature, and these go from about the same time range here, so 1880 to 2010 or so. And you can see again that there's a growth in temperature. So temperature is rising. This is temperature anomaly, just means based on some zero value, which they took to be time around 1880s or so, that they took their zero. This is the famous hockey stick plot from Michael Mann, who's a professor here in meteorology. This shows that the temperature is actually decreasing for a long time. This goes back to the year 1000, and then at this sudden jump. There's some controversy about this plot that's been in the news. We'll talk about this mini ice age that occurred back between about 1400 and 1800 that are not on this plot, and I'm not sure why, but it shows that lately we have a temperature increase. Here's the same kind of data, but comparing land and sea temperature. So land and sea surface temperature. So this is the land surface temperature in red here, and in blue is the sea surface temperature. You can see that they're both rising since 1970 here, but the sea T is up not as fast, but it's still going up. Here's temperature data from deep in the ocean. Now that shows an interesting trend. I like to look at 1970 as a benchmark because that's when the Clean Air Act was passed. So the temperature is, for the most part, ups and downs, but fairly quiet until about 1989 or 1990 or so, and it jumps up. And now it's actually been going down for the last several years. So since about 2006. So T is going up deep in the ocean, and now it's going down. Not sure about why that is. Then we can have temperature from satellites. This is the lower atmosphere, and this shows that the global weather patterns greatly influence the temperature over the years. These show some volcanoes. When you have El Niños and volcanoes, you can have great temperature changes. So there's a lot of fluctuation. And then just recently, again, there's a fairly large spike. So is the Earth really warming? If you look at some of these plots I've been showing you, going back moderately, not going back real far, you see a general trend of getting warmer. But if you go back thousands of years, this goes back to the year zero. And I should mention that the farther back in time you go, the less reliable the data, of course, because they didn't have the instruments and they didn't have as much data collected in the first place. But some people suggest 1,000-year cycle. This paper's arguing for 1,000-year cycle. If you go back even further, and we're talking about here 2500 BC, very far back, you have to use ice cores and tree rings and stuff to get that far back. But this article was very interesting. They show the cyclic temperature, and I think this is temperature, but they never even label their plots. So you got to be very careful when you look at plots like this if they don't do a good job of even labeling their axes. But anyway, we assume this is temperature, and you have some warm periods and some cool periods, and there's this cycle of warm and cool, warm and cool. This is that little ice age that I talked about between 1400 and 1800 where it got really cold. And this article was contributing all these cycles for the most part to volcanoes. So you notice these are all volcanoes that they list here. Krakatoa is one of the most famous ones, another Krakatoa, and then other volcanoes. That what happens is you get a lot of particles in the air that contribute to reflecting the sun and then making it much colder. And then you have El Niños and other warm periods where we can have cycles. So this article was arguing that now where we are here could be just another warming cycle and it's going to cool off again. So what about CO2? So we'll say that the temperature has been increasing lately. If you go back thousands of years, it's less reliable, but it's not quite clear whether the temperature is actually rising in the long term. What about CO2? Well, CO2 is a direct measurement. This is from observatory in Hawaii. I copied this today, which is on January 18th, 2021, which is when I'm recording this. The CO2 level today was 412 ppm. So we're above 400 ppm. Keep in mind, that's a very low amount, 412 parts per million. But definitely nobody's going to argue against this fact that CO2 is definitely going up. No argument there. They can do ice core samples, and if they have trapped air bubbles, they can measure the CO2 in the ice cores. And this goes back to about 1700 here. And you can see that the CO2 is relatively flat, and then it kind of goes up a little bit. And then very recently, since let's call it 1970 again, then we have a great increase. So there's kind of been three slopes in the last 300 years, flat, and then mild increase. So most people attribute this to the Industrial Revolution of 1850 or so. And so people started burning coal, especially much faster rate when they had all these machinery. So they started increasing CO2. And the concentration has gone from about 200 60 something 300 years ago to over 400 now. So it has increased quite a bit percentage wise. Here's another interesting plot. We've learned the word anthropogenic, human caused. So if you compare anthropogenic CO2 emissions, accumulated CO2, and removed CO2, so the purple here shows the total emissions by human activity. So this is your anthropogenic, and that has increased significantly since 1960. These are all based on a zero at 1960. The red, about half of that accumulates in the atmosphere. And then the rest of it, about half, is removed from the atmosphere naturally. So not all of the CO2 that we put in the atmosphere stays in the atmosphere. It gets absorbed into plants and the sea and other stuff. But that's an interesting plot. What I've been searching for, and these are harder to find, is combined plots of temperature and carbon dioxide on the same graph to see whether there's a correlation. So the blue means we're below this arbitrary line they drew here, this flat line of temperature. So we're talking about global temperatures as the blue and red histograms here, and then CO2 concentration is the black curve. So we see some trends, and I can say, well, here we had temperature going down as CO2 goes up. So that's kind of the opposite to what most scientists are telling us. Here the temperature is flat. It's not changing, whereas CO2 is going up even faster. And then only since the 1980s or so do we have these kind of correlating where we have temperature up as CO2 up. And again, this particular article, I didn't put the references for all these. I just grabbed some pictures from the internet, and they don't tell you where they got the data. It depends on whether they're sea or land, or you can often make the data look however you want by picking different types of temperature measurements. Here's another one, a combined plot of temperature and carbon dioxide that I found. At first it says, yeah, they correlate pretty well, but if you look more carefully, we have some regions here where on average temperature was going up, but CO2 was going up fairly slowly. And now we have here temperature going up about the same rate, but CO2 is up quite a bit as temperature goes up. So CO2 was up slowly on this part of the plot. So it's not clear that there's a true correlation. And so if you look at in more detail what this article is trying to show, between 1920 and 1944, here where I have this curve sketched, we had 8 ppm increase in CO2 with a 0.48 increase of temperature. And then from about 1990 here to 2020, we had about the same temperature change, even smaller temperature change, but a 45 ppm increase in CO2. So this article was arguing that CO2 rise and temperature rise are not really correlated, but you can pick any parts of these plots to make your data look how you want it. You can even say here temperature is going down while CO2 is going up. So depending on which data, you can really be biased in these things. And I'm trying to show you that and staying neutral myself. Now, you may have heard some people argue that the global warming is due to sunspot cycle rather than CO2. There's an 11-year sunspot cycle, which you can see here. This yellow curve here is sunspots, and there's roughly an 11-year cycle for that. But the temperature doesn't really correlate with sunspots. And CO2, of course, is just keeps growing and growing rapidly here. But temperature kind of fluctuates at a much lower frequency than the sunspots. But this article is trying to show that they're roughly correlated. If you do a time-weighted average on sunspot activity, again, not real good argument. In fact, sunspot activity is going down on average here, whereas temperature is going up at the same period. So it's hard to tell what's going on. You can get very controversial data. This is a Christian website that looked at the last 1,000 years and showing that global temperature was decreasing rapidly while CO2 was pretty constant or even going down. But their point was that if you plot it this way, the temperature goes up before CO2 goes up significantly. So you can see the blue is CO2 here. That starts going up the years after the temperature had started going up, and then it's fluctuating. And a lot of plots just show this region here. The argument here was that CO2 increase is not contributing to temperature rise because temperature started rising rapidly before the CO2 was even emitted. If we zoom in on that, starting from about 1850, the Industrial Revolution, you can see that there were 3 periods where the temperature rise was roughly the same slope, whereas for the first one, there was a very small CO2 rise. In the second one, it was a little bit larger. And in the third one, where we are now, they look much more correlated. But we have the same three temperature rises, the same slopes. It's kind of independent of CO2. So this person was arguing that CO2, again, is not contributing to the global warming. Now let's look at models. It turns out that climate change models or climate models, computer codes that predict temperature change. This is called a spaghetti plot, by the way. So they have all these different models. There's over 100 models, and this black line is the average. So the point here is that if you take these models and you start in 1975, and then you just run these models and see what they would predict in, this plot was made in 2018, and then compare to actual temperature. And I like this plot because it shows both three different satellite data, and those correlate really nicely with each other. But the overall trend here for the actual data, so these are real data here, these lines, and then the black line is the average of all these plots. They show a much faster growth in temperature than these actual data do. So in other words, the climate models have some problems and they're not as reliable as someone may think. Here's another similar comparison of climate models, but looking at ocean heat content. So ocean heat content has stayed relatively flat, whereas climate models are all predicting ocean heat would go up rapidly. So the climate models are way off in that particular case. Here's a very interesting thing I found more recently. Some people blame global warming on things other than CO2, and they say, well, it's not correlated with CO2 and temperature, as I showed you some of those plots. For example, we talked about the ozone layer and CFCs, and remember back in 1970, 79, we had some things going on with the ozone layer, and they started ban CFCs. So CFC usage really started growing back around 1970 with the rapid rise of air conditioning. And you can see the CFCs, that's what these histograms are. CFC usage was way up as it went up, and putting more CFCs in the atmosphere, which are global warming gases. They are greenhouse gases, very strong greenhouse gases. You can see that the temperature was really rising. So this green is the temperature. And so the temperature was going up as the CFCs went up, correlates pretty nicely. And now, and these are obviously predictions, but this article is predicting that we're going to have some global cooling now because we've banned CFCs, and now they're slowly, I showed you that plot before, they're slowly starting to disappear from the atmosphere. So that's very interesting if that's the case. And the warming is associated with the CFCs rather than the CO2, most important. Another thing that you can talk about, and I find this intriguing, I haven't seen too many articles about this, some people mentioned that. Remember back in 1970, we had the Clean Air Act, and so people around the world have had similar things. So we started cleaning up the air. Well, as you clean up the air, you remove particles from the air, and the particles up in the air are what can reflect sunlight and cause cooling. Take those particles away, now you're going to get more warming. So that could explain some of this warming recently also. In fact, I read an article where people are proposing to put particles in the air purposely way up in the atmosphere to reflect sunlight in order to cool down the planet because they're worried about the planet getting too hot. Let me give you some bullet points here that I'll just point out. Global temperature has been rising, especially in the recent decades, so that's not really disputable, but there are oscillations in cycles. There's the 11-year cycle, and there's some kind of 1,000-year cycle. There's also very much change depending on volcanoes. It seems to correlate with that. CO2 concentration has been rising. That's indisputable, especially since the Industrial Revolution, and then even faster since 1970. Climate models on average greatly overpredict global temperature rise. So something's wrong with the models that they're using. They're not very good at predicting. And then the correlation between temperature and CO2 is what I really wanted to look at. That's kind of debatable. It correlates very well in recent years. It doesn't correlate as well if you go back centuries. And as I showed you, there have been periods where temperature goes down even though CO2 goes up, and temperature up or did not change much even when CO2 is going up rapidly. So I want you to think back what you learned in statistics about when things look like they're correlated, or even if things are correlated. And that is, hopefully remember learning this, that correlation does not necessarily imply causation. So even if we show that temperature goes up as CO2 goes up, that does not necessarily mean that CO2 is the cause of the temperature going up. It could be the other way around. Or it's like saying, okay, my stocks rose quite a lot in the last 10 years and so did temperature, so those are correlated. But there's no causation effect whatsoever. They just happen to correlate with each other because they're both going up. Here's a big important issue here. Everyone has bias, and you can pick the range of data, the source of the data, which temperature plot, whether they're coming from the sea or the air or the land, number of years that agree with your point of view. And people are by nature biased, and you have to be very careful when you read literature about this. So what's the bottom line here? Again, I'm trying to stay pretty neutral here, but have an open mind. So don't just blindly believe everything that you read because of what I just talked about, the bias and people selectively picking data to agree with their argument. So watch out for bias in everything you do. And then, as I said at the beginning, the truth is probably somewhere in between these extremes. So it's probably somewhere in the middle. I personally don't think that climate change or global warming is an emergency and we're all going to die in 20 years. However, I don't think that's just a hoax and that we can just laugh off either. Somewhere in the middle is where the truth lies. Thank you for watching this video. Please subscribe to my YouTube channel for more videos.